Hi guys, at the end of this video you will understand how to calculate an unknown resistor in a circuit as well as the significance of the total voltage and when it should be used in a circuit like this one. So if you like this video, please subscribe and hit the notification bell to be notified of the next upload. So without any further ado, let's jump into the circuit and start calculating. The first resistor that we will concentrate on is resistor R1, so we will calculate that one first. Now for us to be able to do that, we need to understand what do we need to calculate a resistance if it is unknown. The first thing that we need is we need a current flowing through that resistor, and we also need a voltage drop over that resistor. So what do we have? We have a current which is 2 amps. We don't have a voltage drop. So the important thing of calculating this unknown resistor is you need to know and you need to understand the theory behind the circuits. Otherwise, you will struggle to find a voltage drop over that specific resistor there. So the first thing that you need to do is have a look at where your resistor is positioned. What I can see here is I have a battery which is almost sitting or positioned in the middle of two sections of resistors. There I have a resistor positioned on that side of my battery, and here I have resistors positioned on this side of a battery, which means then that the voltage drop over that resistor is going to be my total voltage, which is 12 volt. Meaning, what am I actually saying? I'm saying that that resistor is in parallel with the battery, and when the resistor is in parallel with the battery, it means that the voltage drop over that resistor is going to be 12 volt. So now I can go ahead and say that resistor R1 is equals to my total voltage divided by I1, which is 12 divided by 2, which will give me a resistance of 6 ohms for that specific resistor. Next, we're going to calculate what is the resistance of R2. Now, again, because that resistance, the voltage drop over that one was 12 volt, because it's in parallel with the battery, the voltage drop over this resistor is also going to be 12 volt because this resistor is also in parallel with the battery. But the next thing that we need for us to also calculate the resistance there is we need a current flowing through that branch. So we need to find out what that current is before we can calculate what is the resistance of that specific resistor. And to find that current there, we need to find out what is the current flowing here. What we can see is my total current is 3.4 amps. I have a current of 2 amps flowing in that direction, which means if the total current is 3.4 minus the 2 amps, then it means that 1.4 amps is flowing in this direction. So let's calculate that. So that means that I is equals to I total minus I1, which is equals to 3.4 minus 2, which will give me a current of 1.4 amps flowing there. Now what we can also see is if 1.4 amps is flowing there and I3 is 0.7 amps, then I2 should be 0.7 amps as well. So let's calculate that. It means that I2 is equals to I minus I3, which is 1.4 minus 0.7, which will give me a current of 0.7 amps flowing in that branch there. So now that we have the voltage drop over that resistor and we have the current flowing in the branch, we can now calculate what is the resistance of R2. So R2 will be equal to V total divided by I1, which is 12 divided by 0.7, which will give me a resistance for that resistor of 17.143 ohms. So now I know the resistance of that resistor as well as for that one. Next, we need to calculate what is the resistance of R4. So what do I know about resistor R4? All I know about resistor R4 is that I have a current flowing through that branch of 0.7 amps. I don't know what is the voltage drop, which means I need to go and find the voltage drop first before I can calculate what is the ohms value of that specific resistor. And to do that, I need to calculate what is the voltage drop V3, and I need to calculate what is the voltage drop V5. Only then I will find what is the voltage drop V4 over resistor R4. So the voltage drop of V3 is equals to my current I3 multiplied by resistor R3, which is 2 multiplied by 0.7, which will give me a voltage of 1.4 volts over that resistor there. Next, I'm going to calculate what is the voltage drop V5 over that specific resistor. And that will be that V5 is equals to I3 times R5, which is 0.7 multiplied by 3, which will give me a voltage of 2.1 volts over that resistor. And now I can go ahead and use Kirchhoff's voltage law to be able to calculate what is the value of V4. Now the reason why I can use Kirchhoff's voltage law to find the value of V4 is because when you calculate these three resistors, they are connected in series, which means to get the value of these three resistors together, if you had this resistance here, you would get one resistor, which means that one resistor is going to be the same like this resistor here and that resistor here, which means what am I actually saying? I'm saying that the voltage drop then over that one resistor, which I'm going to get here, is also going to be 12 volt, meaning that if I take my 12 volt and I subtract these two voltages from that 12 volt, I'm going to get the value of V4. So let's go ahead and do that. So I'm going to say that V4 is equals to my total voltage minus the sum of V3 and V5, which will be equals to 12 minus 1.4 plus 2.1, which will give me a voltage drop of 8.5 volt over that resistor. So now that I have that voltage drop, I can now say that R4 is equals to V4 divided by I3, which is 8.5 divided by 0.7, which will give me an ohms value of 12.143 ohms, which is the value of resistor R4. And that, guys, is how you will calculate the unknown resistors in a circuit like this one. Next, I'm going to show you how to calculate the total resistance of the circuit. You will see that what we have here is we have a total voltage which is given to us. We also have a total current which is given to us. So that is going to be the easy way to calculate my total resistance of the circuit. But what I will show you is I will redraw the circuit and I will use the resistors to calculate what is my total resistance of the circuit. So without further ado, let's go to my first redraw and calculate what is the total resistance. Just before I go to the first redraw, let's just have a look at the circuit here, and we can start here. Here I can see that I have a series section here. There I have my series section. So which means that is going to be the first section that I'm going to calculate. These resistors are connected in series, and we know when anything is in series, I will add them. Right, so let's go to the first redraw. Here we can see that those three resistors now became RS1. So we need to calculate that. So RS1 is equals to R3 plus R4 plus R5, which will give me a value of 17.143 ohms for that specific resistor, which is now RS1, which is the series resistor. Now we can see that that resistor and that resistor, as well as for R1, is going to be in parallel with each other. The thing that I want to show you is when I have three or more resistors in parallel, I like to do them two at a time. So that is what I will be showing you. So my first parallel section would look like this. RP1 is equals to RS1 multiplied by R2 over RS1 plus R2, and I'm going to get a value for those two resistors, which is 8.572 ohms. So now let's go to the redrawn circuit and see what it looks like. Now we can see that those two resistors had become R parallel 1. And to calculate the final total resistance, because I have my last two resistors left in the circuit, I'm now going to say that my total resistance, R total, is equals to R1 multiplied by RP1 over R1 plus RP1, which will give me a total resistance for the circuit of 3.529 ohms. And that, guys, is how you will calculate your total resistance, redraw the circuit in a specific circuit like this. Next, I will show you how to calculate the total current, the total resistance by using these two values, my total voltage and my total current. And what we'll also see is you will see if you have calculated the resistance correctly, because what you should get is the same value which we have here. So let's do that and see if we can get the same value. So calculating the total resistance using these two values, my V total and my I total. There I have it. R total is equals to V total divided by I total, which is 12 divided by 3.4. And I'm going to get the same value, which is 3.529. So which means our resistances, which we have calculated in the circuit, is correct. Also our method that we used is correct. And that, guys, is going to be the end of my video. I hope you've enjoyed the video. If you're still struggling, try and watch it over and over again so that you understand the method and why we are using certain things to calculate unknown values in a circuit. Thank you for watching. Goodbye.